All right, welcome back, everyone. So today we're going to talk about the vertical line test and domains of functions. The vertical line test and domains of functions. In this section, we're going to learn how to use the vertical line test to determine if a given graph represents a function, how to determine the domain and range of a function given the graph, how to determine the domain and range of a function or the domain of a function given the equation. We're going to review solving some simple linear equations and inequalities, which we'll tackle again in another lesson later. And we're going to talk about how to use set notation and interval notation to write the domains of functions. Remember that when we're dealing with a relation, a relation is only a function if every member of the domain corresponds to exactly one member of the range. Okay? So that means that the same x value cannot give more than one y value. We use the vertical line test to determine if any x value gives more than one y value. The vertical line test basically says if you can draw a vertical line anywhere on the graph and it goes through more than one point, right, then it's not a function. So let's try this. If we look at these two graphs, for the first one, we can draw a vertical line anywhere, and wherever we draw that vertical line, it's still only going to go through one point on the graph. So this one represents a function. However, if we look at the second picture, and we draw a line anywhere on that graph, it's going to go through more than one point. Okay? This one's not a function. Okay? If we look at the graph itself, there are 2 points that have the same x value, but they're different y values. Okay? Remember, the same x can't give you a different y. And so in this case, that's why this one's not a function. These 2 points, here and here, have the same x value but give different y values. So, use the vertical line test to determine if a graph represents a function. Just draw a vertical line, and if it goes through more than one point, then it's not a function. So, given the graph, we should be able to find the domain and range, right? The domain and range are just all the possible x values and y values. Okay? Because the domain of a graph represents more than just inner values of x, or integer values of x, right? And instead, it represents all the numbers in between. Okay? The set of numbers that represent both the domain and range are usually written in interval notation. To find the domain, find the leftmost x value, then move to the rightmost x value. These two values will represent the domain in the interval notation. Be careful that there are no breaks in the graph. If there are breaks any places where there are no x values, should not be included in the domain and range. To find the range, find the bottommost y value, then move to the topmost y value. These two values will represent the range in interval notation. So let's try this. We're going to find the domain and range of this graph, and we're going to write the answer in interval notation. And so if we look at this graph, the leftmost x value is -3. The rightmost x value is +5. Okay? So we know that the x values go from -3 to +5. And if we want to write this in interval notation, we would just write it as -3 to +5, but we need to have something on the outside. Okay? If you have a point on the graph that's closed in or filled in, that means the graph can be equal to that value at that point. And if the graph can be equal to the value at that point, we use a bracket to represent that side of interval notation. Okay, this means that x starts at equaling -3. Okay. Now, if you notice at 5, we have an open circle, so the graph can't be equal to those values. So it gets really, really close, but not quite to 5. And so when that's the case, we represent that part of interval notation with a parenthesis. So in interval notation, this is the domain of this graph. It starts from equaling -3, and every value in between all the way up to +5. But notice that it's not equal to +5, hence the parentheses. Use a bracket if it's equal to, and use a parentheses if it's not equal to. Now we still need to find the range. The range is very similar. We're going to start with the bottommost y value, which is -4. And we're going to move to the topmost y value, which is 2. I'm sorry, which is 1. And so the range is going to be from -4 to 1. Okay? It can equal -4, so we get a bracket, but it cannot equal 1, and we get a parenthesis. So when you're given the equation for a function, there are two important things to remember when you're trying to determine the domain. First of all, you cannot divide by 0. Any x value that would give you 0 in the denominator of any function must be left out of the domain. The second rule is you cannot take the square root of a negative number. So if any value of x gives a negative number under a square root, that must be left out of the domain. If a function does not have a denominator or a square root, then all the x values are possible. And that just means that x can be any real number or any number we want it to be. Domains are usually either written in interval notation or set notation. Okay, we've done some practice with interval notation already, and we're going to learn a little bit about set notation. As with interval notation, set notation is just a shorthand way to write a large set of numbers. Okay? It differs from interval notation because a variable equation is given along with some condition for the set. So for example, given the linear inequality x is greater than 3, okay, the solution, which is all numbers greater than but not equal to 3, will be written as, in interval notation, just 3 to infinity, right, like we see here. That's how you would write that set in interval notation. Okay? In set notation, we write it as you see here. Okay? And when we read this, the squiggly brackets on the outside imply this is a set of numbers. Okay? And the straight up and down line is read as such that. So when we read this set of numbers, it's the set of x values such that x is greater than or equal to 3. I'm sorry, greater than 3. So we want to find the domain and range, we want to find just the domain of these functions, okay, given the equation, and we're going to write the answers in set notation and interval notation. Okay, so remember, if there's no denominator and no square root, x can be any value. And so if we look here at our function f of x equals 7x minus 3, there's no denominator, there's no square root, so we don't have to worry about dividing by 0. And we don't have to worry about taking the square root of a negative number. The domain for this function is just all real numbers. Minus infinity to infinity, written in interval notation. If we wanted to write it in set notation, we would write the set of x values such that x is any real number. Squiggly bracket at the end. Okay. So this is the domain for our given function. X can be anything. Any x value that you choose, you could plug in and get a y value. So let's try another one. Remember, if there's a denominator, any x value that would give you 0 in the denominator must be left out of the domain. So we have to leave out whatever number is going to give us 0 in this denominator. Our function g of x is equal to 7 over 2x plus 3. And so we want to figure out what x value is going to make the denominator 0. If you're not sure, if you can't just look at it and figure it out, take the denominator and set it equal to 0. If we set 2x plus 3 equal to 0 and we solve it, subtract 3 from both sides, we get 2x equals negative 3. Divide by 2, and you get x equals negative 3 halves. So if x equals negative 3 halves, then we get 0 in the denominator. So negative 3 halves is the value that we need to leave out of the domain. So in interval notation, x can be any value except for negative 3 halves. And so that's minus infinity to negative 3 halves with a parentheses, right, because it cannot be equal to negative 3 halves. And then we use a union symbol, and then negative 3 halves to positive infinity. This union just connects two sets of numbers. Okay, so it's just saying negative infinity to negative 3 halves and negative 3 halves to infinity are put together into one set. That's what that U does. Now, if we wanted to write this in set notation, it would be the set of x values such that x is not equal to negative 3 halves. So when you're trying to determine what's going to give you 0 in the denominator, take the denominator and set it equal to 0. And then leave that number out of the domain. Finally, remember that we have to leave out any number that would give you a negative under a square root. So if you're unsure about the answer in this case, take whatever's under the square root. In this case, we have h of x. There's the square root of 5 minus x. And so if we're unsure about what's going to give us 0 or less, right, we can't have a negative number under the square root, so it has to always be greater than or equal to 0. Then to determine the domain, we can just take what's under the square root and say that it's greater than or equal to 0. And now we want to solve for x. Subtract 5 from both sides. We get negative x is greater than or equal to negative 5. Divide by negative 1. Remember that when you divide by a negative in an inequality, the inequality sign flips. And we get x is less than or equal to positive 5. And so long as x is less than or equal to positive 5, we can always find a value for this function, and so that's our domain. Anything greater than 5, so say 6, for example, if we plugged in 5 minus 6, we would get negative 1. And we would have to take the square root of negative 1, which is not possible. And so we have to leave those numbers out of the domain. So the domain, in interval notation, is going to be written as a bracket, whereas parentheses minus infinity, all the way up to 5 with a bracket. So that's every number less than or equal to 5. In set notation, we would just write the set of x values such that x is less than or equal to 5. Be careful when you're working on your homework that you pay attention to whether the problem wants the answer in set notation or in interval notation. The most common will be interval notation, but some problems will require set notation as well. So at the end of this lesson, you should be able to use the vertical line test to determine if a graph represents a function. You should be able to find the domain and range of a function given the graph. You should be able to find the domain of a function given the equation.